Hello everyone, this is Professor Tiwari. In the last video I did a quick and focused review of the core trigonometric concepts that frequently show up on the ACT. Now I will walk you through some additional identities that are good to know, especially as you move into a college level math. These quick formulas along with some simple strategies will help you solve more advanced problems. Trigonometric identities express relationships between trigonometric functions like sine, cosine, tangent, etc. They are always true regardless of the value of the angle. These are useful for solving trigonometric equations and simplifying expressions. In this lecture, I will be discussing 12 different kinds of trigonometric identities, each of them with examples and tips for quick application. So, here comes reciprocal identities. These show how trigonometric functions relate to each other reciprocally. For example, you can express sin theta equal to 1 by cosec theta. Similarly, cos theta can be represented as 1 over sec theta, and then comes tan theta equal to 1 by cot theta. And similarly, other way around, you can write cosec theta equal to 1 by sin theta, sec theta equal to 1 by cosine theta, and cot theta equal to 1 by tan theta. So, these are very simple, but very useful for solving and simplifying trigonometric problems. These are the Pythagorean identities. They come from the Pythagorean theorem applied to the unit circle. The most basic one is sin square theta plus cosine square theta equal to 1, and from this we get 1 plus tan square theta equal to sec square theta, or 1 plus cot square theta equal to cosec square theta. These are used all the time in simplifying trigonometric expressions and solving equations. To see where this comes from, let us look at this circle which has a radius of 1, and it is called a unit circle. Any point on this circle can be represented as cosine theta and sin theta. So, and the radius of this circle is 1. Radius is 1. Here this radius will be 1, and you can write any point just by looking into this angle theta. When we draw a right triangle inside the circle, this right triangle here going from this point, the horizontal leg is cosine theta by the definition of cosine, because this is theta, and so this, and we know that radius is 1, radius here is 1. So, this will be cosine theta, and then the vertical leg is sin theta, and you know, because radius is 1, the hypotenuse is 1. So, now if you apply that Pythagorean theorem, that one leg square which is sin square theta, then the other leg square cosine square theta is equal to hypotenuse. So, we get this identity, sin square theta plus cosine square theta equal to 1. Then if you divide this expression by cosine square theta, this whole thing, you will end up to this 1 plus tan square theta equal to sec square theta. And then if you divide it by sin square theta, you come to these expressions. So, all three identities are just variations of the same geometric idea from this unit circle. Now, coming to periodicity identities, they show that how trigonometric function repeats their values in cycles. For sine and cosine functions, the period is 2 pi. In other words, sin theta plus 2 pi is the same as sin theta. Similarly, cos theta plus 2 pi is same as cos theta. For tangent, the period is pi. So, tan theta plus pi equal to tan theta. So, these are very useful when working with angles larger than 2 pi or negative angles. Even and odd identities. They deal with symmetry. Even functions stay the same when you negate the input, like cosine minus theta will be same as cos theta. Similarly, sec minus theta will be same as sec theta. So, these are called even functions. Then comes the odd functions when the sign flips when you change the sign of the angle. When you make plus to minus, the sign will change. For example, sin minus theta will be equal to minus sin theta, and tan minus theta will be equal to minus tan theta. So, you just remember that cosine is even and sine and tangent are odd. So, if you have cosine minus theta, it will have same value as cosine theta, but it will not be same in the case of sine. Sine minus theta will be minus times minus sin theta, and similarly for tan. So, sine and tan are odd functions and cosine is even function. Now comes cofunction identities. They show how trigonometric functions relate for complementary angles, that is the angles which add up to 90. For example, sin 90 minus theta is equal to cos theta. Similarly, cos 90 minus theta is equal to sin theta. Tan 90 minus theta is same as cot theta, and cosec 90 minus theta is same as sec theta. So, these identities are very helpful in problems involving right triangles. So, they are very helpful. And now comes sum and difference identities. These are used to find trig values of angles say a plus minus b, the sin a plus minus b or cos a plus minus b. So, for sine and cosine, the formula combines product of sine and cosine. For example, sin a plus minus b equal to sin a cos b plus minus cos a sin b, and then cos a plus minus b can be written as cos a cos b minus plus sin a sin b. For tangent, it is a fraction with 1 tan a plus minus tan b on the top and 1 minus plus tan a tan b on the bottom. These are double angle identities used when the angle is double, like 2a. For sine, say sin 2a can be written as 2 times sin a cos a. For cosine, there are several ways to express. You can write it cos 2a equal to cos square a minus sin square a. This can be simplified to expression 2 cos square a minus 1, and this can also be written as 1 minus 2 sin square a. For tangent, tan 2a can be expressed as tan 2a equal to 2 tan a divided by 1 minus tan square a. These identities help simplify complex expressions or solve trigonometric equations in many problems. Now comes inverse trigonometric identities. These identities help us find the angle when we know the trig ratio. For example, if you know the value of sin theta and your aim is to find the value of theta, you will do theta equal to sin inverse x. Similarly, you can be a case when theta equal to cos inverse x. Similarly, if you know the value of tan theta and you want to find the value of theta, you will do theta equal to tan inverse x. Now, triple angle identities. These are not very common, but useful in some advanced problems. You can write sin 3a as 3 sin a minus 4 sin cube a. Cosine 3a can be written as 4 times cos to the power of 3a minus 3 cos a, and tan 3a can be written as 3 tan a minus tan cube a divided by 1 minus 3 times tan square a. You probably won't see these on ACT, but they do appear in college level math. These are the half angle identities. Use them when the angle becomes half. For example, sin square theta by 2 can be written as 1 minus cos theta divided by 2. Similarly, cos square theta by 2 can be written as 1 plus cos theta divided by 2. These identities are helpful when dealing with square roots of trigonometric functions or simplifying integrals. These are sum to product identities. They help convert sum of trigonometric functions to products. For example, sin A plus sin B can be written as 2 times sin of A plus B by 2 multiplied by cosine of A minus B by 2. Similarly, you can write the sum of cos A plus cos B as 2 times cos of A plus B by 2 multiplied by cos of A minus B by 2. So, these identities are useful in simplifying complex expressions or solving equations in many advanced level questions. Now comes product to sum identities. They convert trigonometric products into sums. For example, sin A times sin B is equal to 1/2 cosine of A minus B minus cosine of A plus B. Similarly, you can write cos A cos B as 1/2 cosine of A minus B plus cosine of A plus B. So, there can be several such identities with just the example. So, they convert product to sum. This wraps up our overview of important trigonometric identities. Some of these you will use often, others are great to know as you move into more advanced math. So, keep practicing and revisit this video whenever you need a quick refresher. And if you found it useful, make sure to subscribe so you don't miss the next one. Thanks for watching. See you soon.